Okay, today's class will just finish off the last slide in this little topic, and then we'll look at writing up the prac that we did last Thursday. So, whereas solubility of ionic compounds tends to increase as the temperature increases, a lot of the gases that we're familiar with, the solubility decreases. The important fact I think you need to know about this. So polar molecules, of course, are highly soluble because they can form hydrogen bonds with water, etc. But non-polar molecules are the ones that are very important for living things. There's low solubility which we depend on, and that decreases as temperature increases. So we've got the first set of the chapter 14 questions, just those few, which let's focus on that first few slides that we've done. I'll post the due date for them. They're now set work. I'll post the due date for them on Google Classroom. What we'll look at now is just writing up that prac that we did last Friday. I'll just get that up. And hopefully everyone's got a good set of results like that. I might post some results on Google Classroom if you just didn't quite manage to get them. So now everyone should have measured their mass of potassium chlorate on the balance. I need the exact mass here, so that might have been 4.013. And that's going to be the same for each one. What changed, of course, was the volume. So for each different volume, you're going to need to calculate the solubility using the formula like we did in class. So for the first one, the calculation is going to go 4.013 divided by 10 times 100, and that of course will equal 40.1 grams per 100 grams. So that's solubility which goes in here, and then you'll calculate it exactly the same way for each of those. Once you've done that, of course you've got the temperatures already recorded from class. Once you've done that, you'll be able to draw your graph. So I've even scaled the axes for you. All you've got to do is plot the points. And then sketch the curve. Using a pencil, sketch the curve as best as you can. I'm not going to practice that, we did enough of that in class, and yeah, so get a nice smooth curve if you can. Once you've got your curve, you'll be able to read off the curve 55 degrees. Whoopsie daisy. So 55 degrees, go up to the graph and then read off the solubility on the y-axis. That's the answer to question 1. Question 2, of course, dairy is important. We need to be sure, we need to be having the exact temperature of the solution. So having a well-mixed solution means that the temperature is uniform throughout. Now, a supersaturated solution occurs if you aren't stirring it as it cools down, and if you've got an absolutely wonderful source of distilled water, there's no nuclei for crystallisation to occur. So what will happen is it will just keep on cooling down, cooling down, cooling down, below that point at which it's a saturated solution, to the point where it's more than enough of the potassium chlorate is dissolved. So that means you'll keep on lowering the temperature before crystallisation occurs. Obviously, the temperature will be much lower in that case. And question 4, cooling it down, we're seeing a very steady, even drop in temperature. Uniform temperature throughout. It's much more accurate and much more precise to measure the temperature at which it recrystallises. As you're heating it up, it's in the Bunsen burner, hot water's bubbling around, you're stirring and stirring and stirring, and it's impossible to know. You're not doing it, you would have to do it really, really slowly, just increment the temperature a little bit each time, stir and stir and stir and see if it's still dissolved. You'd see it didn't, then you'd increase it a bit more, and so on. It would be a much more involved process, much simpler, much more accurate and precise. Okay, so get that prac written up, and again, I'll put up deadline information on Google Classroom.